All right, we are going to evaluate functions for all six trig functions for any of these special angles. We have the angles in degrees right here in red and radians in blue. This is called the unit circle. The unit circle provides us with a ton of information. These are coordinates that are basically special angles. And when we use these coordinates, we can envision little triangles that come through here. And when we think about these, the x is always kind of like a base in this, or the adjacent side of the angle, and the y is like a height. Okay, and so I'm going to go through this and we're going to use a reference quite a bit on this. So when we're looking at this, here's kind of a scaled back one. We have our opposite adjacent. Again, the adjacent side's the x, the opposite side's the y. Thinking about these little triangles, and if this is the angle of concern, we can use this circle and this kind of xy idea to evaluate functions at different degrees. Now, in this unit circle, the radius is always 1. So I want you to keep that in mind when I do things like opposite over hypotenuse, that the hypotenuse is 1. All right, so the sine of any angle is, well, SOHCAHTOA. It is opposite over hypotenuse. So the opposite in this case is the y coordinate. We're going to just say that's like y over 1, but really you can just think y. And the cosine is x because, well, it's the adjacent over 1, which is x over 1. The tangent is going to be opposite over adjacent, so it's going to be y over x. Now I'm going to work my way over. We talked about these being the reciprocals, and so we're going to call this x over y. Now we kind of get a funny thing going on here. Now you could write it like this, but just remember that these are what we call reciprocals. So if you find the sine, and a lot of these values on this are like fractions on the unit circle, sorry. Where did my unit circle go? Here they are. A lot of these are fractions, so you're going to flip them when you're looking for the inverse functions. So how do we go about this? So we have this thing that says evaluate the function, and we're going to not use a calculator. We do have to remember a little about how radians and degrees work. But we can find all six by using this info. So pi is the one I'm looking at. So what I'm going to do is I'm going to go ahead, I'm going to grab my unit circle, and I'm going to evaluate for pi. So I find pi on my unit circle. That's halfway through a circle. I look at my xy coordinate, okay? So for the coordinate that I'm looking at here, xy, and you know what I'm going to do? I'm going to go ahead and just write that down here. It's -1, 0. That's the x, that's the y. All right, so as I go through this, I'm going to go ahead and use my reference here. Say, all right, well, the sine at pi is the y coordinate. That's 0. So just go ahead and say sine is 0. Cosine's going to be -1. The tan is y over x, so that's going to be 0 over -1, which is just 0. The cosecant, now we're going to start flipping some stuff. Now we kind of get some issues here. If I flip 0, I get 1 over 0. Well, that's going to be called undefined. Remember, you can't divide by 0. If I flip -1, well, that's still going to be -1. It's just going to be 1 over -1, so that's still -1. And again, we'll get one more, where when I flip this, I get -1 over 0, and you get undefined. A little bit of a weird one, because these all seem so similar. So let's look at an angle that's got some more unique stuff going to it. So I'm going to find 135 on my unit circle. I'm going to write down, for me and for my reference here, I'm going to go ahead and write down the xy coordinate, which is -√2 over 2 and √2 over 2. And we're going to go through this whole thing again. Remember, sine is the y, cosine's the x, tangent's the y over x. Just putting this a little bit closer for me to look at. And so I say, all right, the y coordinate, √2 over 2. Easy enough. Cosine, x coordinate, -√2 over 2. Tangent. Okay, so this gets going to seem a little tricky. When I do the y over the x, these are big fractions, but they're the same number. One's a negative, one's a positive. I could write it out as -√2 over 2 divided by √2 over 2. And one of these is a negative. The x is negative. That's just -1. Okay. A little wild there. Now we're going to start flipping. Cosecant is the reciprocal of sine. So we're going to flip that guy. So that's going to be here. I'll draw a little line so you can see where my things start coming apart a little bit. All right, so cosecant is going to be 2 over root 2. Well, we got to rationalize that. And when we rationalize this one, we're going to end up kind of getting in a little bit of a circle here. No pun intended. It's just going to be root 2. And I'll keep that in mind when I do my work for secant. Since secant's basically the same but negative, we're going to go ahead and say the secant of this one is negative root 2. And cotangent at negative 1 is going to be, well, it's going to be negative 1. There we go. So those are my functions at 135. We have a negative angle here now. Remember that negative angles don't mean the same angle make them negative. It means go backwards through your unit circle 150 degrees. If you have trouble figuring out like what's where to go on your unit circle, if you take negative 150 and add a full rotation, 360, it's going to say it's the same as 210. That's the same as going backwards 150. So let's look at that. So if I was looking at this, going backwards 150, forwards 150 is like almost half the circle. Backwards, here, and we just did that math, it should be 210. So let's write down our coordinate, negative root 3 over 2, negative 1 over root 2. You don't have to write down the coordinate. I'm doing it just so I can reference it right here. So these are both negative in this case, like that. And we'll go through again. So let's get our y coordinate is negative 1/2. Our x coordinate for the cosine is negative root 3 over 2. Our tangent, okay, I'm going to divide these two, but they both have denominators of 2, so they're going to cancel out. So the y coordinate here is, we're just going to say it's negative 1 over root 3. And they're both negative, negative 1 over negative root 3. Just think that the 2's will divide out evenly. This becomes a positive, and we're going to rationalize this by doing that. And so we get root 3 over 3 as our evaluation for tangent. All right, let's keep that going. Cosecant's going to be the inverse of that, so we're going to flip that, so it's going to just be negative 2. Secant, we're going to end up having to do a little more rationalizing here. Again, these are negatives. No negatives canceling out. But I'm going to rationalize by multiplying by root 3 over root 3. Nothing's going to cancel out. I'm sorry. But we get an answer. It wasn't too painful. And lastly, cotangent. We're going to do x over y. Again, the denominators will cancel out, so we can just say this divided by that. So root 3 over over 1. And so they're both negative. So we'll just call this positive root 3. All right. Again, refer to this. Feel free to lean on this. This looks a little messy, so just think about them as the reciprocals of sine and cosine. So let's do them that are a little more complicated. We don't have to do all 6 each this time, but we got some ones that are going to come at funny angles, and I'll do some extra work to figure it out. I'll show you my strategy. My strategy, when I think about this, if I know it's bigger than a full circle, I just take away a full circle each time. So I say minus 360, that gets me into the 210. So that's between 0 and 360. So we're going to refer to the angle at 210 here. And we want tangent. Tangent, as we mentioned earlier, tan is going to be the y over the x. And the coordinate that we're looking at is saying root 3, negative root 3 over 2 and negative 1 over 2. All right. Again, these are x, y coordinates. This is the y coordinate. This is the x. All right. So that's all we got to do so far. And we're going to say, all right, y over x. So we're going to say negative 1/2 over negative root 3 over 2. This would be like if you're showing tons of work. Again, the 2's are just going to cancel out. These negatives over negatives will become positive. So what does that give us? That gives us 1 over root 3, which when we rationalize it, because we are rational humans and we just don't like dividing by roots. That's the issue. We get root 3 over 3. Sorry, my color coordination just kind of fell apart. This is my final answer. Again, that is the solution to saying what is the ratio at 570 degrees of the opposite over adjacent. All right, we got secant. We can start by finding the angle, or we can say that secant is going to be the reciprocal. Secant says 1 over x when we look at like our little guide, which just means the reciprocal of x. What about negative 405? Again, we can just keep adding 360. Still have a negative angle here, so I'll add 360 one more time to find my reference. So 315. So I'm going to go to the angle basically like 315. Those are the same angles. So if I find 315 here on my unit circle, say, hey, the coordinate here, and this is just me writing down the coordinate so I have it to reference. Put this at 2. Here's the xy I'm referring to. But I only needed the x coordinate, so we're only focusing in on this guy right here. But we don't want just the x coordinate. We want the reciprocal of x. So we're going to flip it, and then we have to rationalize it. So we're going to multiply by root 2 over root 2. What the heck is that? That was scary. Okay, so 2 over root 2 over 2. Those 2's go goodbye, and we're left with just straight up root 2. All right. That's a smiley face. All right. Uh-oh, we got something in radians. I believe 8/3 pi does not fall under on here. 8/3 pi is not here. Remember that, and I'll put this work down here, 2 pi equals 360. Okay, so that's a full rotation. If I want to find a coterminal angle, an angle that's the same as this, what I can do is I can take away 2 pi. Since this is in thirds, 2 pi, we'll put it in thirds. 6 pi over 3. Okay, so if I want to find something that's the same as 8 pi over 3, I'm going to take 8 pi over 3. I'm going to take away 1/6 pi over 3, which lets me with 2 pi over 3. This is the same angle as that. When I take away 2 pi, I get the same angle. It's just, or the same endpoint, a coterminal spot. So let's find on our circle. 2 pi over 3. Where is it at? Where you at, bud? Here you are. Right here is our coordinate, 2 pi over 3. That's the one we're going to use. And our coordinate there, let's write it off to the side, is negative 1/2 comma root 3 over 2. Okay, that's the coordinate we're referring to. That's an xy. And for cosecant, we need 1 over y. So therefore, we're only concerned about the y coordinate. And we want the reciprocal of the y coordinate, which is 2 over 3. So we're going to flip that. So we're going to say the cosecant of 8 pi over 3 is 2 over root 3. Got to do some rationalizing again. So we're going to say root 3 over root 3. And what we're going to end up with is 2 root 3 over 3. And that's our final answer. That is the solution to cosecant of 8 pi over 3 is that. Got one more. Again, cosecant again, a negative 1. So this case, if I was going to add 2 pi each time, in pi fourths, 8 pi over 4 is equal to 2 pi. So that's what I'm going to do right now. So if I have negative 13 pi over 4, if I added 8 pi over 4, I know I wouldn't get to around the circle one more time. So I'm going to have to add one more 8 pi over 4. So each of these represents a whole circle rotation so that we can use our unit circle. Okay, so I'm really adding 16. So if I said negative 13 plus 16, I would get 3 pi over 4. Again, you can kind of just ignore the pi's when you're adding. Okay. So we're going to look at our unit circle. So that just changed my angle. I have to find 3 pi over 4 on my unit circle, which I believe, let's find, is right here at 135, 3 pi over 4. And since we know we're only looking for the reciprocal of y, I'm just going to jot down the y coordinate. So the y coordinate we're looking at, the y coordinate at, again, 135 or 3 pi over 4, those all are the same thing. The y coordinate is root 2 over 2. Well, we want the reciprocal of that because cosecant is 1 over y. So we're going to flip it. We're going to say 2 over root 2. And then we'll rationalize it like that. And at a certain point, you don't have to show this work anymore. At least I won't ask for you. And you get root 2. All right, so try the practice problems. You could download something called the unit circle. This is the info. It's going to be the same each time. There's radians. There are degrees on it. Try to get one. Or you can draw your own. Just Google it and draw your own. Get it tattooed on your hand. That'd be cool.